In this video, we will continue to talk about exponents and their properties and talk about some more rules of exponents. First, let's simplify 2 cubed to the second power. So 2 to the third power is now our base, and that base is being raised to the second power, which means 2 cubed gets multiplied by itself twice. By the product rule of exponents, if you have 2 to the third times 2 to the third, when you multiply the same base, we keep the base and add the powers, which will give you 2 to the sixth. Another example, we have 3 to the fourth in parentheses raised to the third power. Our base is now 3 to the fourth, so we will now take 3 to the fourth and multiply that base 3 times since that is a power. When multiplying the same base, we add the powers and keep the base. So 4 plus 4 plus 4, this will give you 3 to the 12th. What's happening here is we're taking this power and this base and multiplying it by itself 2 times or 3 times, which leads us to adding 3 twice. Here we add 4 3 times. Repeated addition is same as multiplication. So to take a shortcut, we can just multiply 3 and 2. We can multiply 4 and 3. So if we have 3 to the m raised to the n power, when raising a power to another power, we multiply the two powers. This leads us to the power rule of exponents. For any number a and any whole numbers m and n, a to the m raised to the n power is equal to a to the m times n. In other words, to raise a power to a power, multiply the exponents and leave the base unchanged. Here are some examples. X cubed to the fourth power is x to the 12th. We'll multiply 3 times 4 since we have a power raised to another power. 4 squared to the 8th power, we have a power raised to another power, so you multiply the two exponents. This will give you 4 to the 16th power. Here's a product to power rule. For numbers a and b and any whole number n, a times b to the nth power equals to a to the nth times b to the nth. In other words, to raise a product to a power, raise each factor to that power. For example, let's simplify the quantity 3x to the fourth power. Because we have a product of 3 and x in the parentheses, we will take each individual factor and raise each factor to the fourth power. Just be careful and write each factor in parentheses when raising to the fourth power. 3 to the fourth power is 81. X to the fourth power is x to the fourth. So our answer is 81x to the fourth. Let's simplify the quantity negative 2x cubed to the second power. Once again, we have two different factors. We have negative 2 and x cubed. When you have a product to a power, we take each individual factor, negative 2 squared and x cubed squared. We raise each factor to the second power. Be sure to use parentheses when doing so. Negative 2 squared is 4. The power rule tells us if you have a power to another power, you multiply the two powers, which will give you x to the 6th power. Let's take a more complicated example. We have a squared b cubed to the 7th power times a to the 4th b to the 5th. The order of operation states, first, let's simplify any exponents, any parentheses, but the parentheses cannot be simplified. After parentheses, now let's simplify any exponents. So let's take a squared b to the 3rd and raise it to the 7th power. The product to power rule states that if you have a product of two terms and that entire quantity is being raised to the 7th power, then we will take each separate factor, a squared to the 7th times b cubed to the 7th, and we still have our a to the 4th, b to the 5th. A squared to the 7th power, we're taking a power to another power. You multiply the powers, get a to the 14th. B cubed to the 7th power, we take 3 times 7, which is b to the 21st, and that is still being multiplied by a to the 4th, b to the 5th. Now we will multiply the same base, so a to the 14th times a to the 4th will give us a to the 14 plus 4. When multiplying the same base, keep the base, add the powers. Same with base b. When multiplying the same base, we will keep the base and add the powers. Our final result, 14 plus 4 is 18. This is a to the 18th power. 21 plus 5 is 26, and b to the 26th power. Next, let's talk about the quotient to power rule, which states for any real numbers a and b cannot be 0 since we can't divide by 0, in any whole number n, the quotient a over b to the nth power equals to a to the nth divided by b to the nth. For example, to simplify the quantity 3 over b to the 5th to the 4th power, we will raise 3 to the 4th power divided by b to the 5th raised to the 4th power. Each individual factor is raised to the 4th power. 3 to the 4th power is 81. 5 times 4 is 20. This gives us 81 over b to the 20th power. Letter B, we have 2a to the 5th over b to the 4th raised to the 2nd power. Each individual factor will get raised to the 2nd power. So we have 2 squared, a to the 5th squared, divided by b to the 4th squared. Each individual factor is being raised to the 2nd power. 2 squared is 4. a to the 5th to the 2nd power, we would multiply the 2 powers. That will give us a to the 10th. b to the 4th to the 2nd power, we would multiply the 2 powers. That will give us b to the 8th. And this will be our final answer. So once again, take each individual factor and raise it to the 2nd power. The exponent zero, for any real number a with a not equal to 0, a to the 0 always equals to 1. Any non-zero number raised to the 0 power is 1. For example, let's simplify 1, 2, 4, 5 to the 0 power, and that equals to 1, because anything to the 0 power is 1. Negative 3 to the 0 power is 1, because any number to the 0 power is 1. 4w to the 0 power is 1. Negative 9 to the 0 power. Now here we got to be careful. Notice that the 9 is not in parentheses. So what's actually happening here is we have a negative, I'm going to say there's a negative 1 there, times 9 to the 0 power, because the exponent 0 is only for the base 9, not for the negative sign. So negative 1 times 9 to the 0, which is 1, will be negative 1 times 1, which will give us negative 1 as the answer. Here is a brief summary of the properties of exponents. Please copy this in your notes if you don't have this all in one place.